This is a CHP combined cycle. So we are going to have two different stages of useful mechanical energy being produced. And then, of course, we can use that useful mechanical energy to to drive a generator and make electrical energy as well, right? So we're going to have, in this case, I'm going to draw you a gas turbine and a steam turbine, where the gas turbine is going to run a generator, or it's going to have its own, work output from a shaft. And then the heat, and that's a topping cycle if I take the heat from it, right? So I'm going to take the waste heat from that gas turbine, and I'm going to use that waste heat in order to make some steam, high pressure steam, for a steam turbine. And the steam turbine can then also creates work energy. And then from that steam turbine, I'm going to steal some of the intermediate pressure steam from that steam turbine, and I'm going to use that for some process heating. So if I am taking some steam from a steam turbine, the steam turbine was doing work, but I'm going to take it and do some extra energy from it. I'm going to do some process heating. I'm going to take some of that heat energy out of it. So that's a topping cycle again. And then we'll close this loop nicely. So we're going to do a gas turbine to a steam turbine. We're going to use the waste heat recovery from the gas turbine, run the steam turbine, take the intermediate pressure steam to take some of the heat energy from that and feed it all back. That is a topping cycle into a bottoming cycle into a topping cycle. So let's look at what that looks like then. So we're going to start, of course, with a fuel. A fuel is going to, is what we're sort of paying for here. So I like to put fuel in red, whether we're making that fuel or not. Our fuel isn't really, the best part of this cycle. It's sort of a necessity at this point that we are paying for this fuel. This fuel is carbon intensive. Let's make the most of this fuel. And if we burn this fuel, we combust this fuel into a gas turbine. I can feed that combustion process here with air. So this is in and this is in order to give the oxygen required for the combustion process, right? So I'm feeding this combustion process, and out of this combustion process, I can use the energy to drive a turbine, okay? And this type of turbine is called a gas turbine. So this gas turbine is using literally the exhaust gas from the combustion process in order to run this turbine. And coming out of this turbine is going to be our first amount of work energy that we can use. So why do we burn this fuel? We want this work energy. And again, there's blades inside this turbine, and as the gas hits the blades, you are pressing on those blades mechanically. You are spinning those blades. If you have a shaft then attached to them, you're spinning the shaft. Now this work can do some direct work energy by turning some equipment, or more commonly, we would connect that to a generator in order to make electrical energy out of it. But wait, there's more. Coming out of here, you still have quite a bit of heat energy. We still have a lot of heat coming out of this gas turbine, because this is a gas turbine using this gas fuel from combustion, right? So it's like an exhaust. It's like an exhaust where it's hot. Okay, so we can put a boiler here, and that is basically the waste heat or the exhaust can be used as a boiler. So we are adding, that is a heating process. And we can take the heat from there in order to make some steam if we put some water in it. So let's put some water in there. Let's just choose a different color. Let's put some water in there. And if I put some water in there, then it's going to come out, right? It's going to come out as high pressure steam. And I can take that high pressure steam now. And what do I like doing with high pressure steam? I like driving turbines with high pressure steam. So I can now drive a turbine with this high pressure steam. And this high pressure steam, of course, is going to go and hit the blades of that turbine. That turbine is going to be attached to a shaft. This shaft is going to rotate, doing useful mechanical work. You can put that useful mechanical work into an electric magnet in order to make a generator, and that will produce some electricity. Coming out of there, we're still going to have a little bit of energy, right? We're still going to have some energy coming out of here. It's going to be low pressure. It's going to be, well, we're actually not going to steal low pressure steam. We're actually going to take some intermediate pressure steam so that it's still somewhat useful to us. So we're going to take some intermediate pressure. We're going to take some intermediate pressure steam and do something useful with that. So what can we do with that? Maybe there's some process heating we can do. Maybe there's some space heating that we can do. So let's put a heat exchanger on that, and let's do some process or heat, process or space heating. Right? And then as we do that, it's going to lose its energy. So Q is going to be leaving. We're going to lose that heat energy, but we're happy to lose that heat energy, right? This makes us happy. Making work over here made us happy. Making work over here made us happy, right? We did some good stuff. And then it's going to lose its energy. So that water is going to end. That steam is going to end up being liquid, right? It's just going to be liquid water at this point. That liquid water we can put into a tank. Instead of draining it. And from that feed water tank, that's what we can pump. Yes, we can pump that. We can pump that water up to make it into steam. And of course, we're probably going to have to have some makeup water here for any of the losses in the system. So what did we do here? Let's see. Let's see. We did some work over here. We did some work over here. We did some process heating over here. Yes, that was nice. So we have done 3 different things here in this combined heat and power CHP system, our combined cycle of a CHP system. Now let's talk about the types of CHP systems these are. Remember when we go from a turbine to when we first make mechanical energy, and secondly we make heat. So we first make mechanical, and then secondarily we make heat. That is called a topping cycle. That's called a topping cycle, right? But then when we first make heat and secondly make mechanical, that's a little bit more rare. We first make heat, secondly, so first we make heat and then we make mechanical. That is called a bottoming. cycle. And then finally, we have another cycle in here. So we've actually combined 3 different cycles. We have another one in here where we are first making mechanical energy, and secondly, we're going to be using the heat again. So this is another topping cycle. So just cleaning up this diagram a little bit, we see that our combined cycle for this CHP system has a topping cycle into a bottoming cycle into a topping cycle again. It creates some useful work. From the waste exhaust of that gas turbine, we have done another bit of useful work because we could make steam from that waste heat. And then we've taken some of that intermediate pressure steam and we've done some process heating or some space heating, and then closed the loop back to a feed water tank. And that is our combined cycle.